All right, so here we go. So this is taking what we learned last week when we started looking at the how many seconds are in so many years and applying it directly to chemistry. And so one of the things that this man named Amadeus Avogadro figured out a few hundred years ago, a couple hundred years ago, was that you needed a way to say how much of something you had when you're talking about microscopic little atoms. And so weight is not a very good way to do it because they weigh so little. And so you needed to have enough of these atoms that would make a difference. And he came up with the concept of a mole. Now, obviously, when we think about a mole, we might think about a bump on our face, or you might be thinking about a silly little creature like that. But that's not what we're talking about. The mole is the SI unit for the amount of substance. The SI units are like meters, liters, grams. It's the SI unit for how much do you got is a mole. And they're so small it's impossible to count them, so we count them instead by moles. So 1 mole of atoms, if you have a mole of atoms, it's going to be 602 hexillion. 602 hexillion atoms. So we're talking not a million, billion, trillion, quadrillion, quintillion, hexillion. It's a number that's so stinking big, it's hard for us to understand it. And the reason for that is because atoms are so stinking small. It's hard for us to understand how small they are. And so we don't usually use that word because that number, because that number is hard to type in the calculator. So instead we use scientific notation, 6.02 times 10 to the 23rd. And if you only learn one number from chemistry, let it be that number. This is kind of the number that's going to guide us really for the rest of the year. 6.02 times 10 to the 23rd. And I'm going to say it's atoms down there, but it can be also molecules, particles in a mole. 1 mole has that many either atoms or molecules in it. And it helps, it's what helps us, be able to count and be able to talk about these things that otherwise we wouldn't be able to talk about it because they're so stinking small. So this is kind of a silly joke that was in the notes. It says how big is a mole? Well, it's about the size of a chipmunk, blah, blah, blah. Obviously, we're not talking about that mole. So we want to know how big pretty much is 602 hexillion of something. So the easy answer is really, really, really big. But if you did talk about how big it is, let's think about something we do know, marbles. We all know how big a marble is, okay? And if you had 6.02 times 10 to the 23rd marbles, it would cover the entire planet, including the oceans, 2 miles deep. So we're talking 10,000 feet up, covering the entire planet, including the oceans, with marbles. It's an enormous number. Now, some people just like talking dollars, right? So if you had 6.02 times 10 to the 23rd dollar bills, and you stacked them face to face, not end to end, but face to face, made a stack of dollars. So that's 2 stacked up. If you made a stack of dollars and you had 602 hexillion, it would go from the sun to Pluto and back 7.5 million times. So it's an incredibly large number for us to wrap our minds around. Really, the only thing I need you to know is that the reason this number is so stinking big is because atoms are so stinking small. Y'all with me? All right, let's carry on. But we do all of this so that we can talk about atoms, because if you didn't have this number, everything you talked about with atoms would be an incredibly small number. Let's say, how much does hydrogen weigh? You would say, 0.0000027 zeros, 1 gram. And it just wouldn't be worth doing. And so we have the idea of a mole to make things worth doing. So for any element on the periodic table, so all those elements up there, the 1 mole has a mass in grams equal to the decimal number on that table. So let's look up here. One of the things we're going to do with the periodic table is talk about how, I can't get too far away from my mic, talk about how this is the greatest cheat sheet in chemistry. This periodic table is the greatest cheat sheet in chemistry. If you look on a periodic table, the red numbers up there are what you call atomic mass. Look at hydrogen in the top left corner, 1.00794. Let's go ahead and get this straight. We're going to round to 1 number past the decimal. So the mass of hydrogen is 1. The mass of helium is 4. The mass of oxygen, 15.999. What would that be rounded? 16. Okay, so 1 number past the decimal is what we're going to round these guys to. But that tells you how many grams if you had a mole of it. Okay, so look at hydrogen. Hydrogen has a mass of 1 gram per mole. That means if you have 602 hexillion atoms of hydrogen, it would weigh about the weight of a paperclip. That, I mean, we're talking incredibly small guys here. Gold, AU, is 196.96, so 197, 197 grams if you had a mole of gold, because gold's pretty heavy compared to other things. Okay? So here's your periodic table. Right here on the periodic table is your mass. If you have a mole of neon, it weighs 20.2, round to 1 number past the decimal. You have a mole of argon, 39.9. And on down the line, krypton, 83.8, xenon, 131.2, and radon, 222. The ones with parentheses around them, those are atoms we're going to talk about it more at the end of next week. Those are atoms that only have 1 type. And so that's why it doesn't have a decimal. All right, so this is our island diagram. And I know that the practice today says island diagram practice or something like that, but the way to think of the cool thing about the island diagram is it gives you everything you need to convert one thing to something else. And you don't have to remember anything because it gives it all to you. Moles tell you how much you have in grams, we just talked about that. But they also tell you how many things you have in particles. If you have 6.02 times 10 to the 23rd particles, that's a mole. If you have whatever it is on the periodic table, that's a mole. So we can use this to convert whatever we have to figure out whatever else we have. And it's an island, so you got island creatures. So let's check out an example of this. If I have 1 mole, and I'm going to write, since we can't really look back and forth, I'm going to kind of draw the island diagram up here. You have grams, mole, and particles, or atoms. Okay, so the conversion is, to go from there to there, we're going to look at the periodic table. And to go from here to here, we're going to use 6.02 times 10 to the 23rd. So it says how many moles are in 3.79 times 10 to 25th atoms. So we're going to do the same thing we did the other day. We're going to write down exactly what we have. 3.79 times 10 to the 25th atoms. Okay? I remember what we drew. How do we convert things? What do we draw? Martin, I know you remember because you were here. What did I draw to convert things? Parentheses. Parentheses with a line through it because we're making a what? What is that? Equation? I don't have an equal sign. What is it when you put a line up there like that? Fraction. I'm making a fraction. I got atoms. I don't want them. Where do they go? Everybody with me? Anytime you got something that you don't want, You put it on the bottom. And then you read the question, what do I want? I want moles. Now we just put a number that converts one thing to another. Let me give you a hint. Anytime you're talking moles, you only have one. Until way later in the year, anytime you're talking moles and you're converting to or from one mole. And for atoms, what's my magic number? 6.02 times 10 to the 23. Okay. What's the only math I have on the board? Multiple choice here. Addition, subtraction, multiplication, division. Division. There's no multiplication on the board because this times this is a waste of my time, right? The only math on the board is taking this and dividing it by this. Everybody grab your calculator. I'm going to show you the cheat code for the calculator, okay? Because you probably know in math class, you probably learned a little bit about scientific notation, but I'm going to show you the cheat code on all these calculators. Martin, stick with me, man. All right? Type in with me. Everybody ready? 3.79. Now don't hit the multiplication sign. 3.79. And then there's a button above the 7 that says EE. Everybody see it? Second. I think it's the second button. I think it's above the 7, isn't it? Yeah, the second button above the 7. See above the 7 where it says X minus 1? The second button of that one says EE. Okay, so your calculator should say 3.79 and then hit that EE button and you'll get a little E that looks like that. Very good? Now what are we going to exponent? 25. Okay. Now, what that E tells you is times 10 to the. That's what E's saying. 3.79 times 10 to the 25th. This and this are exactly the same thing. The only difference is if you type this in your calculator, how many numbers is your calculator going to think you're talking about? If I type this exactly like it looks in the calculator, it's going to tell the calculator you're dealing with 3.79 and 10 to the 25th, two different numbers. But you guys know, because we just were talking about it, that 3.79 times 10 to the 25th is just a way to write one number. It's just a scientific notation. We got to tell the calculator we're talking about only one number, and this is how you do it. Everybody good? Now you're not done because we have to what do we have to do tonight? You told me? We got to divide. So you're going to hit that divide button on your calculator. And we're going to type the other half of it. 6.02. Not times 10. Second EE. 23. So your calculator, before you hit enter, your calculator screen should look just like this. Now, but your calculator screen actually gives you a line instead of a divide, I think, doesn't it? Okay, but your calculator screen should look just like that before you hit enter. Everybody good? What do we get? Okay, so just a rule of thumb, give back what they give you. They gave me 3 numbers. I'm going to listen for 3 numbers. 62.95 rounds up, right? If you put 62.9, I'd count it right. If you put 62.95, I'd count it right. If you put 63, I'd count it right. I'm never going to take off points for rounding. Okay? As long as you give me the right answer, you're going to get it right. Here's the thing, though. We talked about this last week. I'm not done because 63 is never an answer in chemistry class. What am I missing? Which is? Moles. Moles. Piece of cake? All right, let's keep it rolling. Let's make sure that their math agrees with us. Oh yeah, I gotta delete my stuff I made. There we go. All right, they did the same thing we did. Bam, bam, bam. Set it up right. Look at that. Kicking tires like fires. They said 63 moles of zinc, but there's only talking about zinc, so I'm fine with that. All right, let's try another one. How many atoms is 0.68 moles of zinc? So this is the same question backwards. Okay, so instead of up here they were asking how many moles in atoms. Right here I'm asking how many atoms in moles. All right, so I'm gonna do the exact same thing. I'm gonna start off by writing down exactly what I have. 0.68 moles. Then I'm gonna draw my fraction with the line through it. What's going on the bottom?
6.02 times 10 to the 23rd.
Always write your units, then get your numbers. Because if you do it backwards, it will throw you off. So starting with my numbers, excuse me, my units. I got moles, I don't want them, where do they go? Moles to the bottom. Now that you know that moles are on the bottom, you can remember something I said about the first one. Anytime you have mole, what number goes with it? Rock and roll. And what am I trying to change moles to?
Atoms.
And how many atoms are in a mole?
6.0.
There you go. All right, what's the only math on the board? No.
Actually, multiplication.
You with me?
Yeah.
Because there is no division on the board, because what's the only number under the fraction? What's the only number under the fraction?
1.
1. And with 1 under the fraction, what do I need to put in the calculator? Yeah, I don't 1 under the calculator. I don't care about 1 under the fraction. Poof, it's gone. Okay? So all I'm going to do here in my calculator is say 0.68 times 6.02 E23. Don't type times 10. That's a waste of your life. 6.02 E23. So what I would type in the calculator, like I said, 0.68 times 6.02 E23. So everybody get, well, slow down because I'm going to get you to read the whole screen here in just a second. Because let's think about this. When we had lots and lots and lots of atoms, we divided it by a huge number and we got a regular number, 63. We got a number a little bit less than 1, which is, I mean, relatively close to 1 though, 0.68 moles. So we expect our answer to be really high or really low or in the middle. Look at what we're doing here. We're multiplying a number pretty close to 1. I mean, I know it's not 1, but it ain't far off. Comes an enormous number.
So big.
My answer is going to be enormous, right? So read what you said.
4.09.
Okay, stop. Because I have, now I hear you, thank you. But I'm going to have somebody on this test next week write 4.09 and be done. And I want you to look at that and see how 4.09 does not make any sense. Because you need your number to be really, really big. You're going to need your number to have that exponent. So make sure you read to the whole end of the calculator screen and you say 4.09. Go ahead and say it now. Times 10 to the 23rd. Somebody finish me off? This is a test question. That's -1. I did everything right except for, say it loud. What is it? Very good. And you can put AT, you can put atoms, write it out. It doesn't matter. Okay? Rocking and rolling. Stop me if I do anything wrong, guys. Y'all got to let me know. Let's see it nice and pretty for us. And they rounded a little bit more, no stress, no stress. You will never be rounded, never be graded on rounding. Okay? So let's do some grams. How many grams in 5.69 moles of uranium? How many grams in 5.69 moles of uranium? First thing, write down exactly what you have. Draw my fraction with a line through it. TJ, what's going on the bottom? What unit is going on the bottom? 50-50 shot? You good with that? Moles or grams? Yeah. Moles is what I have. I don't want them. They go on the bottom, and I kind of already use a 50-50 shot, so you know what goes on top, right? Grams. That's what I'm looking for. What I say was the magic thing about moles if I'm changing it up? How many moles we got? 1. For this test, and really for the next few tests, moles will always be 1 in your conversion. Now, look over there on that whiteboard. Where do I look to find how many grams are in a mole? The periodic table. Have you found U yet, Ashley? Can you read that red number to me? That's good. And that's it. And the only math on the board is what, Martin? What's the only math on the board?
238.
What's the only math on the board? And what are you going to multiply?
5.69 times 238.
Hook me up.
So 1354.22.
1,354.
0.2.
I don't care about the 0.2. Grams. Like I said, don't stress on rounding, guys. Don't stress on rounding. Even if you told me the answer was 1,350, I ain't gonna be mad at you. Okay, if you put 1,354.2, rock and roll. I don't care. Rounding is never gonna be something I take off for. But the key thing here is we know why she said 238. She said 238 because she knew we're talking grams. We got to look on the periodic table. I told her U was uranium, but you can always look that up. And you always have a periodic table available to you if you need one. Number 92 is uranium, but I don't care about that number 92 number. I'm gonna care about that number 92 number next week. This week, I care about that red number, 238, and there it is. Keep it rolling. All right, how many grams in that many atoms of neon? Now, here we go. We got one. So we're going to write down exactly what we got. Daniel, what's going on the bottom?
Oh, you gotta put
Always do your units first. What's going on the bottom?
grams on the one.
What do I put on the bottom? What I got or what I want?
What you do? Wait.
Let me rephrase it. What am I going to put on the bottom? What I want or what I don't want?
What you don't want.
What I don't want. And I don't want what I already have, right?
So,
What's on the bottom? Atoms. Now, Denali, ready for the trick question? It's a 50-50 shot. Can I go straight from atoms to grams? What do I got to go through? Got to go through moles. I can't go straight from atoms to grams. I have to go from atoms to moles. What's my magic number for moles? 1. What's my magic number for atoms in a mole? It's over there. That 6.02 number. Now, if I stop there, what would my answer be in?
moles.
Is that what the question wants?
No.
So how many? We got to take another step, right? So I'm gonna draw another fraction. Where am I gonna put moles? On the bottom. And this time now I can go straight to grams. 1 mole. How many grams in a mole of neon? Neon is Ne.
20.
Give me one number past the decimal.
20.1.
2.
7.
20.2. And no stress. If you had done the 20.1 or even 20, you would have come up with the right answer. I would count it right. I'm not grading you on round. Okay? Now, what math is on the board?
Multiplying and dividing.
Very good. Which have we better do first?
Dividing.
PEMDAS. You with me? I don't really care about the PE in the PEMDAS, but I really do care about the MDA. Okay? Multiplying comes before dividing. It makes your life so much easier. And you got to think about this mathematically rather than 3 separate things as one giant fraction. So if you want to think about it in your mind, it's like you're going to type it into a calculator. What am I going to multiply? What's my multiplication? What number am I multiplying? Nope. Where is 6.02? Yeah, am I going to multiply if it's at the bottom? What am I going to multiply? Don't say 1. 20.2. It's the only thing that I'm multiplying. It's the only thing on top. Now, here's where you got to be very careful about how you type this in your calculator, because you need to make doggone sure that your multiplication happens before your division happens. You cannot do the division and then the multiplication. You have to make sure you multiply before you divide. So what I'm going to do in the calculator, if I have my calculator, is I'm going to type 2.65 E23 times 20.2, and then I'm going to go ahead and smash that enter button to make sure I get that multiplication done first. And then whatever my answer is, I'm going to divide by 6.02 E23. And my guess, don't tell me, I'm thinking that my guess is going to be something along the lines of 7 or so, 7 or 8. You can tell me. Woo, look at that in my head. 8.9 grams. Thank you. 8.9 grams. So let's make sure we understand where everything came from. I had to take 2 steps on this one because I had to take 2 jumps on the island. I had to go from particles to moles to grams. There is no link between these 2 islands. I can't go from particles to grams. I got to go through moles. Particles to moles to grams. Okay? And then I just use my conversion numbers to get me there. I think there's one more. Come on, dude. Oh, is that the end? That might be the end. Nope, here's one more. How many atoms in 421 grams of promethium? I'm going to go ahead and give you a hint that promethium is PM. And I'm going to stay doing it up here. I know, TJ, it's hard for you to see. Feel free to move around if you need to or stand up, whatever you need to do. Okay. So how many atoms in 421 grams of promethium? Start off with exactly what you have, 421 grams. Draw my fraction. What's going on the bottom?
Grams.
Grams on the bottom. What's on top?
Atoms.
Can't do it.
Oh, we got to get a moles first.
Very good. Grams on the bottom, moles on top. Magic number for moles. Anybody find PM yet? 145. Nice, easy number to work with, right? Anybody know? I think we talked about it last week. I don't know if we talked about it this week. Anybody know why there's white letters up there? Why promethium is white instead of the regular black letters? The white bordered one, well, the black bordered white letters up there means that those guys are man-made. Those guys don't really exist in nature, and you have to make them by smashing other atoms together. So promethium is very, very rare, but the one that we have weighs 145 grams. Am I done?
No.
Because I got to take it to.
2 atoms.
Very good. What's on the bottom? Sorry for my sloppiness. What's on the bottom?
Moles.
Moles on the bottom, atoms on top. What are my numbers?
1 and 6.02 times 10 to the 23rd.
Same as the last one, except for
It's
what I'm multiplying a little bit different. 423 times 6.02 E23. Smash the enter button, divided by.
145.
You with me? Four 421 times 6.02 E23. Smash the enter button, divided by 145. What you got, Ashley? 1.7. And I'm hoping you're not done talking. I'm hoping you're not done talking. Yep. Times 10 to the 24th, I think, isn't it? Yeah. So that times 10 to the 24th is very important. And you're right, we are talking atoms. But that times 10 to the 24th is extremely important because 1.7 is, here's, let me give you $1.70. And 1.7 times 10 to the 24th is 1.7 septillion, which is an enormous number. Make sense? Everybody feeling good? So check out your practice. Got about 30 minutes or so. I'm gonna bring up a practice sheet for you. So if you go to your modules, today's practice is called, I believe, island diagram practice. Yeah, just island diagram is what it's
So
called.
would you rather us do it on paper, take a picture of it, and then click the link, or would you rather us just?
Whatever way you want to do it. Yes, it says work on a separate sheet of paper. I'll be honest with you, the reason the separate sheet of paper is there is because this is hard to do digitally. Okay, and I don't really care to see to see the answers, and I'll show you why I don't really care to see the answers. I don't want to just see your answers, I want to see your work. So take a picture of it, show it to me, because if you look at this paper, I got 18 questions. Yeah, do your best. Check out what's at the bottom. Because the answers, anybody can get the answers. I want to see how you're going to do it. Okay? So that's why I really need you to show me the work on these. Okay? You want to do one more, or you feel like you got it? Speak up. You want to do one more, you feel like you got it, guys? I think Daniel said he's got it. Ashley? CJ? You want to do one more?
If it's math, I got it.
Okay. Okay, let's stick with me, TJ.
I'm working on older ones as well.
Okay, well, let's do number one, okay? Sound good? Do number one. Find number of atoms in phosphorus and 3.44 moles of phosphorus. Okay? So 3.44 moles. Draw my fraction. What's going on the bottom? You always put what you have and what you don't want on the bottom, which is what? Moles, exactly. And anytime I write mole in a conversion, I'm going to write the number 1. Now look over here. What's my magic number for atoms in a mole? 6.02 times 10 to the 23rd atoms. Punch that in the calculator and do a dance. 18 looks like a lot of questions, but when you realize how quick you can do these, it's really not that bad. Most of them are just one step. They might all be one step. Wait, look. Now the last 13 through 18. So the last 5. So we'll say do the first 12 for sure. The last 5 or so is where you have to do 2 steps. First 12 are really easy. 13 through 18, you have to do 2 steps. Okay? If you get stuck, let me know. Practice it out. Take a picture of it. Put it on the, share it to me and get full credit. Everybody feeling good? All right. Y'all faking music? Being so quiet worries me. It don't bother nobody else. It don't bother Martin because he's over there rocking and rolling already. I can roll. If you need me, I'm here, guys. And next week, don't hesitate to get up with me. Anybody want to take one of these calculators home and sign with me? Okay? Anybody want to take one of these calculators home and sign with me? You'll just bring them back when you come back. These calculators are great for doing this work. If you get stuck, let me know. I'm here for you. Oh, I'm going to stop the video and make the video real quick. Oh, I got somebody here. Matthew Britton, he's here. Got any questions, Matthew, before I cut this off? You don't want to talk to me. I'm not Matthew.
There's some like.
Oh, there's somebody in the chat. Hold up. What does this do? What we're doing right now? Today? But no worries if it takes you longer. But yeah, anything like this where it's a bunch of math questions, dude, I'm just really looking, does it come in rather than, I mean, I ain't trying to beat people up on late scores. What you got, man?
There's some like mass and density questions here too.
What number?
Dude, what is the mass of 0.38 moles of?
Yeah, right here. Mass is just grams. Mass, I can actually write that. Mass is the same thing as grams. Well, grams is measured in mass. See if that. Said okay. All right, Matthew.